So my classes look like this. I'm a professor in the math and science department. I teach math classes. This happened just a couple of days ago in my class. And this is what they look like all the time. If you walk into my class, you will never see me lecturing. You will never see, but you will see a lot of this. I have videos of it, but it doesn't make for compelling TV. There's no sound bites. It's a bunch of students being like, okay, so I did this. Yep, I did this and that. And other students saying like, oh wait, are you sure? To watch something happen takes about 10 minutes. So today I'm going to show you pictures. So this is what happens. So here, I have a question for all of you. Okay. This is a choice for you. Given the choice between working on a problem that you already know how to solve or on a problem that you don't know how to solve yet, which one would you rather work on? Please decide for yourself. Are you ready? Okay, how many of you would like to do the one that you already know how to solve? How many of you would like to do the one that you don't know how to solve? Okay, great. So all of you picked the one on the right. So this is what I want. I want my students to have this growth mindset, the idea that you want to work on something new. You're not just practicing something that someone has already told you how to do. So this is what I want. So I've collected data on a lot of different things, which you can see if you want to know about presentation skills or scores on exams or how much they use phones in class. You can read the paper. But this is this statistic that I collect data on, and I've collected it in a lot of places. So you all are the black dot at the top. Thank you for going into my data. And then this is the other classes that I've taken. So this is on the second day of class. They fill out this thing. And this is the percentage of students choosing what I would call the right answer, the growth mindset. So you can see it has ranged from all the way down to 19% all the way up to 86% on the first day. That's a big range as a baseline. And so you might wonder what happens as the course goes on. Well, and they're color-coded. As you can see, all the dark red ones are Swarthmore, the purple one is Williams, and the blue ones are Northwestern. So here's what happens. Here's when this happened. I mean, the data isn't like super linear. So you kind of have to figure out what's going on. But you can see that for the inquiry-based curriculum that I've taught, they basically all go up. Except for this one, they all go up. And except for adult academics, stays at 100%. And for lecture, they basically stay in the same place, or maybe even go down. Because, well, who knows? I didn't say why because, but maybe because we're just telling them stuff and telling them to practice it. So, or they want you to give them problems that they already know how to solve. So you might wonder, okay, given that that's what I want, how do we achieve that? So there's two aspects to my curriculum. One is student-centered discussion classes, and the other is incremental problem-based homework. So what I want to happen is I want them to discuss things in class. And in order to make that happen, the work that they do has to make that happen. So student-centered discussion classes, here's an example, and I'll just show you some pictures. So that has two things. When they come into the room, they're randomly, by coin flips, assigned to small groups of 4 to 8 students. And then within those groups, they explain their solutions to each other, ask questions, correct errors, and discuss. Okay, so this kind of a situation that you see in this picture is what I want to happen in the room. It turns out that if you just tell students to do this, it doesn't really work. Believe me, I've tried it. I tried it actually for a while, and sometimes it does work because they're kind of intrinsically motivated to learn, but some students aren't really into doing this kind of thing, and so they don't do it. You say, come on, please, ask questions, discuss, and they don't do it. So I'm a big believer in incentives. So here's the incentive. So at the beginning of class, they're writing up their solutions on the board. You can see that. Sometimes they write them up individually. Sometimes, as you can see, they collaborate with each other. They're thinking there. You can see that you scratch your head when you're thinking, so that's good. Here you can see these two students are writing up the problem together, this orange problem. So are these two writing up this problem together. And then after they finish writing up their solutions on the board, they get into groups and present them. So here's the incentive. When I have a pirate or a student TA in the room, then I can do the following thing. I have them be in this group of 6 to 8 students, seven in this case, and each student explains the problem that they put on the board. And then there's a second round when I come along and I choose a student to present each problem that's written on the board, but not the one who put it up. You see? So here's Ariel explaining this green problem, and when I come around, I'm going to ask Davina to explain it. So Davina is highly motivated. If she doesn't understand what Ariel is saying, she's highly motivated to ask clarifying questions. At this point, I'm paying attention, but I'm like far away, and they don't even really see me. So this really does make active things go on. They ask each other questions. If something is wrong, they correct it because they don't want to be the one presenting the wrong thing later. So it actually works pretty well. So here's this happening, and I'll just show you a few more examples of that. You can see the students are sort of lecturing to each other. I'd much rather have them be the ones lecturing than me, because they are more happy to ask each other questions to each other. And they do a good job. Usually they do a really good job. We can even do this outside. And one thing I'll say is also that in addition to being a big believer in incentives, I'm also a big believer in classroom culture. So the incentive, from the beginning, the incentive is they must ask each other questions because they're going to have to explain these things later. But once that culture is created, I don't actually have to do it every time. So for instance, in this case, the entire class is listening, and we're not going to go back and have everyone explain it a second time because the classroom culture has already been created that they ask each other questions. And that really works. And I tried that this semester because I didn't have a student TA in my class. And so the first couple of weeks, I was like running back and forth, getting students to explain more questions, and it was ridiculous. But then once the culture was created, they do it by themselves. It's kind of awesome. So there you have it. There's that picture again. Now, this semester, I'm teaching a class that has, 30 students in it. And so in a class of 30 students, I really can't have 2 15-student sessions going on at a time because there's just too many questions. So I break them into small groups of 4. And in this case, they don't write up their homework on the board and present it to each other. But they are told they have to write down the solutions to their homework and hand them in. So the incentive is that handed in homework is going to get a grade. And so they all need to understand the homework. And it's been very successful. They sit in these little groups of 4. They go through the homework problems one by one. They, by themselves, decide that they should go up to the board and draw pictures and explain things. They, by themselves, pick up the marker and correct other things. It's pretty awesome. So it's certainly working. And they're saying, anyway, they think it's better than any other configuration, like groups of 15, groups of 8. They really like these groups of 4. So then the next thing is, how am I going to get them to do this? Like the problems have to be good. I can't just have them read the textbook or watch a lecture and then do some practice problems for this to happen. It's not going to work. So what I do is I do incremental problem-based homework. So I'll just give you a simple example. There are more examples. I have many. So suppose I give you this question. How many lines can you draw between endpoints? So there's mathematical words for this, but I'm not going to use them today. So if you have endpoints, in this case 11, and you want to just draw one line between each pair of points, how many are there going to be? Okay. The answer is n times n minus 1 over 2. But if I just assign this problem, which is part of the discrete math curriculum that they really must be able to do, this would be too hard. It wouldn't be a good problem because some students, like maybe strong students, would figure out a way to do it, but other students would be completely stuck. You see? So it wouldn't really be a good problem. So here's what we're going to do. On the second day of class, here's an exploring problem. How many lines can you draw between 5 points? How about 11 points? So here's the picture for 5 points. Oh, this should say points, but that's okay. So for 5 points, they figure out you draw 10 lines, and then they do a bunch of more examples. So for 4 points, 6 lines. For 6 points, 15 lines. They start drawing pictures, and then eventually most of them have this idea. So suppose I have some number of points, like 11. Well, the first time I'm going to draw lines, I have to draw them to the 10 other points. So there's 10. And then for the second point, I have to draw it to 9 others. We already have one to the first point. For the next one, 8, 7, 6, 5, 4, 3, 2, and then for the last one, just 1. And so they usually make this observation that the total number of lines is 1 plus 2 plus 3 plus all the way up to n minus 1, in this case 10, because they're going to be lines. Cool, okay, so they've solved this problem, and they can just add this up. 1 plus 2 plus 3 plus 4 plus 5, all the way up to 10. Fine. So that's day 2. That's like the second day of class. Then, here's the next problem. Totally different, not the same thing at all. Suppose we have n people, and we all shake each other's hands exactly once. How many handshakes occur? Nice to meet you. Hi. 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 Okay, you might notice that if there are n of us, I have to shake n minus 1 hands. So do you. So do you. So n times n minus 1 total handshakes have to occur. But when I shake your hand, I count it and you count it. So we counted it twice. So it's n times n minus 1 over 2. Exactly the thing we wanted, but in a totally different context. Okay, so then finally, maybe that's day 4, like the second week of class, give them a little break so that they're not thinking about it. Now give them this question: how many lines can you draw between n points? And some of them will have this idea, oh wait, it's the same as the handshakes. The purpose of this is to create problems where they have to have some kind of idea, and yet you've given them the ability to have that idea. So they don't have to just pull it out of nowhere, they pull it from somewhere. It's like, what do they call that? Priming. You prime them with something, but you don't prime them like with a previous problem. I wouldn't give these 3 on a homework assignment. I give them spaced out so that they have to have the idea. Oh wait, that thing we did 2 weeks ago. So they have to have some kind of. And then I might eventually, just as an abstract thing, have them prove this fact, that the 2 different things are equal, and then they'll have to think back, oh wait, how can I think of 1 plus 2 plus 3 plus n minus 1? Oh yeah, there are the handshakes and the lines and everything. So, to summarize, I have incremental problem-based homework, like really meaty problems that make them have ideas. Ideas and skills are developed through the problems, so I write them carefully so that I don't have to have lectures. A given topic is developed over the course of several weeks, so in that example I had day 2, day 4, day 7. And there are many topics developed simultaneously. So as they're developing this like line counting thing, they're also developing whatever other kind of topics are in the class, all layered on top of each other, all ramping up the knowledge a little bit at a time, layered. And then in the student-centered discussion classes, the students explain things to each other, and I just do things when I need to. It's pretty great, and it's really, really fun.
What expectations do you set, in particular for your class, for the students to kind of prepare coming into the class in terms of reading or different? I know that you say that some of them kind of scaffolding at home, and so those are kind of collectively, like how do you hold them responsible for kind of coming to the room with enough of a foundation to then work through the problems? And then the other is, have you had to make any kind of compromises with how much content you're going to cover over the course of the semester as you research?
Yeah, absolutely. So the stuff that they're writing on the board is the homework. So right. Homework is 8 to 12 problems per night, each of which has a very specific purpose in my mind. They can't really see it. These kind of problems. So that's the homework. They don't have to watch lectures. They don't have a textbook to read. They're welcome to do any of those things, but the only thing they're expected to do is work hard on all the problems. They are supposed to solve them if possible, and if not, work on them to the point that they're really stuck. Not stuck on what the problem is asking, but stuck on how to solve the problem. So that when they come in, they're ready for another student to give them a little push that will help them solve the problem. So that's the expectation. How do I have to change things?
Yeah, like how much you cover in this.
Oh, how much you cover? Yeah, well, sometimes you can and sometimes you can't. So for instance, right now I'm teaching 2 sections of discrete math and 1 of multivariable calculus. Discrete math, there's no set curriculum. There's no stuff you're supposed to cover. You're supposed to teach them the right roots, So if you cut something, like if you the three things you have to cover to be theorems, and pretty much everything else is in service to those things. So either you cut something and then you just wave your hands about it, like, oh yeah, we're going to use this formula, but we're not going to say why. That's your only choice to cut things. So it's kind of brutal, but I think it's just as brutal knowledge because you just